Welcome on the talk about platform engineering. I'm Maarten Vandeperre. I'm Specialist Solution Architect in Application Development and AI within Red Hat. Besides working, I like to play tennis, padel, like an occasional beer, or not so occasional, so whenever you want to discuss one of these topics of today, I'll be available at the Red Hat booth the entire week, so feel free to discuss over there or after the presentation. I have three things that I really like to speak about at conferences. It's platform engineering, AI, service mesh implementations, and I can assure you that at least two of the three topics will be tackled today. All blog posts, recordings on conferences are available at maartenvandeperre.be, and this recording will be put over there as well. Slides of this presentation are already uploaded over there. If you want to have them, they are available. So, let's get started. Platform engineering, and where did it originate from? Well, in the past, developers were happy. And this is a meme that I link to happy developers for some reason. But development work itself was pure coding, and all the rest was dealt with by operations teams. And these teams were slow, were not cooperating, were not flexible at all, hence the frustration meme. Because whenever you wanted to have a database, it could take weeks, months before you had it. Whenever you needed a VM to do something, again, you had to wait, and you had to run through an entire process. And then we had, the cloud. And it was going to solve everything, because we told management, whenever we got the flexibility to not wait for these ops people, things will go faster, we will be way more efficient. And then we had the rise of the cloud, we got our hands on the cloud console, and we had the flexibility we wanted. Management, for once, listened to us, and they told us now, hey, you now get the flexibility, now show that you can improve the efficiency. And in the end, cloud development looked more like this. Because now we had to think about storage, we had to think about security, how do we orchestrate all these components, and so on. So what do we have on the agenda for today? First of all, how did we get in the unhappy scenario after getting all this flexibility? We go through some developer struggles, give a definition and theoretical outline for platform engineering, and we go to a developer portal and a developer tool. Demo, bear with me, will be half of the presentation, so it will not be all slideware. So, what happened? Well, management was listening to us, and we now got the flexibility through the cloud. And it was, now you have access to the cloud console, you can build it, but you as well have to run it, you have to maintain it. The cognitive load was increasing because we now had to study about storage, networking, security, all these things. So in the end, it resulted in you build it, you probably run away from it. Because it was not just software development anymore. Dev became DevOps. DevOps became DevSecOps. Okay, some people will kill me if I say DevSecOps because security should be part of all the pillars, but you know where I'm going. Then you have DataOps, FinOps, nowadays MLOps, up until an abbreviation that doesn't fit the screen anymore. And we have quite some big screens over here. So what happened? In the past, developers were responsible for application development, software development, building the artifacts, and then throwing it over the wall to these operations teams, who dealt with the rest of the application lifecycle. With the cloud, we got our hands on the cloud console with thousands of components inside, and we had an increase in cognitive load. So we were a bit overloaded, burdened with all these responsibilities. On the other side, the ops teams were now confused. Because if you give a cloud console to a developer, up until where does the responsibilities of the ops teams go? I already mentioned it, you have tools. Tools, way too many tools. If you open Google Cloud, Azure, Amazon, you'll see that you have hundreds or thousands of components that you can choose from. These components need to be integrated within your platform in order to do your software development, your software maintenance. To highlight that it's quite a selection that you have to maintain, that you have to study from, I've took a snapshot from the Cloud Native Compute Foundation, the Cloud Native Grocery Store, which is just a subset of components that you can use in your cloud native development, mainly orchestrated around Kubernetes. To showcase that it's quite a huge list, we've hidden an Waldo, Wally, Charlie, depending on the language inside, because it will be quite hard to find it over here. Slides are online. If you want to search for it, you have to close your eyes for a couple of seconds, because we didn't cheat. Charlie is inside. So next to that, we had some developer struggles that we wanted to fix. First of all, it's CI/CD tooling. When you went from the Tomcats, the JBoss servers in which you were deploying your applications, you now had to deal with containers. With containers, you required a container technology. In the past, it was Docker. Nowadays, it's rather Podman, new tool to learn. Then you had the container technology. But with the rise of the microservice and mini-service paradigms, you now needed orchestration as well, which is then Kubernetes. And when you finally got your hands on Kubernetes, then you see where is Waldo slide. So then you have to find out service meshes, security, storage, and all these things around it. When mentioning containers, it's not just building these containers. It already starts from which base image will we take, because these can already be compromised. For Red Hat, we have universal base images, which are free to use, which are already hardened, security scanned for vulnerabilities on the operating system and the packages that are inside. Next to that, how are we going to build them and deliver them to our orchestration systems, and so on. Then, a topic that's not really popular within development means it's security. But nowadays, security is more important than ever. Maybe show of hands, who's using AI-generated code in its day-to-day job? Quite some hands. And from these people who are validating the dependencies that are dragged in within the AI-generated code. Okay, still quite some hands, more than at other conferences. But that's as well an issue with nowadays AI-generated code, vibe coding, that we don't check enough which dependencies are dragged in through these AI tools, or which image mirrors or so on are getting used. So the CI pipeline becomes more and more important to automate all these checks, as you will see in a second in the demo. Then we have some other struggles as well, like for example, too little automation, creating new environments can still take too long, and so on. So in the end, cloud development looked more like this for the majority of developers. If we then have a look at what summaries are inquiries are saying, is that top 3 of developer burnout was increased workloads, too much responsibilities for developers, a lot of pressure for digital transformation towards cloud native, and a lot of requirements to learn new skills. Remember the Where's Waldo slide, a lot of components to monitor and to maintain, integrate within your development environments. If you then ask them, you did dev, do you now want to become DevOps? Because you saw how easy it can be. Then around 42% was saying yes, 42% was saying no in a polite and a less polite way. How can we overcome these struggles? It was all negative up until now. Let's shift to the positive side. I don't think it's a surprise if you saw the title of the presentation, but platform engineering can help over there. You have quite some definitions of platform engineering, but I mainly stick with you give self-service to developers or other personas. It's an abstraction layer on top of your platform, and it's an abstraction layer on top of your application lifecycle. It's often asked, and is it in competition with DevOps? And that's not entirely the case, because these platform teams will use DevOps principles to build a developer platform. So you can rather see it as an extension on DevOps. How does it go? Well, building a platform starts with building a recipe. And that's already the first step where it goes wrong in some organizations. Because building the recipe is sitting together with your developers, questioning what their struggles are on a day-to-day basis. these struggles need to be solved with the capabilities that the platform will offer. We sometimes see that a platform is built in an ivory tower and pushed towards developers, which is resulting in a low adoption rate of the platform. It should rather be capability push from developers. Which capabilities are mainly default in developer platforms? Well, nowadays with mini-services, microservices, you need orchestration, for example, a Kubernetes engine. You need observability. You need some vulnerability scanners, especially when you're using AI-generated code, runtimes, image registries, and so on. Then when you have the capability list, when you have the recipe, you need to bake the platform. And here the infra or ops people arrive in the scene. And for example, for the CI capability, you have the good old Jenkins Bamboo. You can use Tekton pipelines, you can use GitLab pipelines, GitHub Actions, and so on. These infra ops-oriented people of your platform team can now pick one or more components and bake it into your platform. But that's not sufficient, because we now build the capability list, the recipe, we bake the platform, but we still have what we call bookmark hell. Imagine you have 5 to 10 microservices that you are developing. It's 5 to 10 CI pages, a couple of CD pages to get deployed to a test environment, a pre-prod, a prod environment. Then you have documentation living in SharePoint, in Confluence, GitHub, and so on. To find and navigate your way to your IT landscape is all based on bookmarks to find the information. With a developer portal on top of your platform, this can be solved, because this portal now will become the single pane of glass, a single view on your IT landscape. And this is what we will show in the demo later on. I already touched it, the developer platform. In the slides now it will be an IDP, but be careful. If you read about IDPs, it can be the developer platform, can be developer portal, or can be an identity provider. So whenever you read a text about IDPs, try to make sure that you know which IDP they're mentioning, because it can be a bit confusing. So what is an IDP? Yeah, I should have put platform inside. It's a central collection of services and automated workflows that enable self-service and abstraction layers on the application and the application landscape. How you can see it, for example, in the past, if you want to have, let's say, MongoDB, Elasticsearch database enabled, well, we had to install everything on a VM. First abstraction layer could be, hey, we now have a cloud console, a platform, or we have OpenShift with the operator framework. We just select the database and we run it over there. But then you still need to decide on how much CPU, how much memory, how much storage do I need to put underneath it. So it's already abstracted, but there's still some cognitive load left. Now we can put a portal on top of this and say, hey, for your developers, we have 2 options that they need to select. Which database and which t-shirt size of the database. And these 2 parameters are then translated towards the options, these parameters that you need to develop or enable it in the cloud, which is then the extra abstraction layer that the portal can bring. Developer portal, just the single view, single pane of glass on your IT landscape. Be aware, portals, platforms, difference. If you read about IDPs, make sure that you know which IDP, which component you're talking about. With the portal, you have yet another tool, so it should bring benefits for devs. And as far as we've seen, it brings benefits. So now you have a more structured, layered layout, where devs are again in the happy spot, with the only responsibility there is developing software. You have the ops with clear guardrails. These are your responsibilities. This is what you have to work on. And then I will call it a silo, but I'll come back to that because it shouldn't be a silo. You have the silo of the platform engineering, where you now have the build tools available, the orchestration, monitoring, security, and so on. In the image, in the presentation over here, it is a silo, but it shouldn't be a separate team per se. It should contain people from the dev side, from security, from ops, from infra, even from business. And that team should then bring the platform, build the platform for the entire organization. Why? For example, devs, let's say senior developers, technical leads that become part of the platform engineering team, can list the capabilities that the platform needs to offer. They see the struggles on a day-to-day basis, so they can list the recipe. In the other direction, these developers, these technical leads, can then advocate for the platform, increasing the adoption rate of the platform within the development communities. That you need ops and infra to build the platform, I think that's a no-brainer. And then security people, yeah, it's not bad to have them inside the platform as well. We often get the question, do you then need to have new hires if you want to start with platform engineering, with platform teams? Yeah, it's a yes and no answer. You can hire platform engineers because they have the experience in building these platforms, but it shouldn't be entirely new hires, not only platform engineers. Make sure that you bring personas from different silos within your organization together. Last important topic on this is make sure you have a dedicated product owner for this platform. The platform and the portal should be the main component, the main artifact that you're building within your organization. If this is not stable, if this is not managed properly, adoption rate will be slow and it will just cost money. About money, if you need to convince management on doing platform engineering, these are some quantitative dev benefits that can help the message to the management. Or if you want us to help with this, feel free to reach out to Red Hat as well. Not everything is good or is perfect in the platform engineering world. It will not solve everything. First of all, you will need to invest money. You will need to invest time in it as well. It's not with enabling a portal like Backstage that suddenly all struggles within your company are gone. You need to rethink processes. You need to implement the platform. You need to have adoption rates within your development organizations, development teams, and so on. Then there are tools to help. On the platform side, you have reference architectures, which you find from the hyperscalers. This is one from Humanitech, which is then divided in developer control plane, integration delivery, monitoring, logging, and security. You had one from the Cloud Native Compute Foundation. You have one from platformengineering.org as well. That was for the platform side. On the portal side, I think there's one big player at the moment, which is Backstage. It was started by Spotify and then contributed to the CNCF landscape, to the CNCF project. So yet another tool in the Where's Waldo slide. And it's an open platform for building developer portals. It is powered by a central software catalog. You can enable, disable plugins. In the beginning, it's an empty box to which you have to add functionality. Disadvantage of Backstage is that you have to enable, disable plugins through source code, and you need to configure it through source code. For this, with Red Hat, we created Developer Hub, but everything we do within Red Hat is open source. So we saw that there are struggles with the plugin management, the configuration management of Backstage. So we wanted to extract it in YAML definitions, because it's running on Kubernetes. In Kubernetes, you configure everything through YAML definitions, so that you don't have to touch the source code of the application. In the beginning, this refactor was too huge, so the community didn't accept it. So we created a midstream open source project, which was called Janus, to enable what we call dynamic plugins. So configurations and plugins through YAML definitions. Nowadays, they saw the adoption rate, so it's getting pushed into the Backstage project. So whenever you search for Janus, you will see that it's deprecated. Next to that, with Developer Hub, we harden it and we productize it under the Red Hat portfolio. But when I talk about the portal, if we can just show it as well. So let me open Developer Hub Backstage. For the ones familiar with Backstage, it will look 100% the same. The main difference is then, up until now, the dynamic plugin configurations. So first thing that you can do is create applications, create microservices, mini-services, whatever you want to do through self-service listing here. We call it software templates, but we should rather change the name to, for example, scaffolding templates, because it's not only software anymore. It's not only applications anymore. You see it, for example, that infra people come to this portal as well to create Ansible playbooks. That you have self-service with this on API key management and so on. So I think even Developer Hub needs to be renamed as well, because it's not only targeting developers anymore. So here we can start an application, but let's first see if we, for example, everything is AI nowadays. If we want to have a chatbot, then we need to have some storage. We need to have connections. We need to have model serving, for example, through VLLM on Kubernetes. And this all is wrapped in OpenShift AI with this productized Kubeflow. Then, on the OpenShift side, you need pod deployments. You need pods, you need services, you need routing, you need security, all of this. Just to get a simple RAG application up and running. And I already mentioned 10 to 20 components. So in the end, the landscape looks a bit like this. You have runtimes, security, all what I was mentioning. It is all already integrated, maintained in OpenShift, OpenShift AI, Kubernetes, Kubeflow, but the cognitive load is still too big. If we now create a scaffolding template to do this, it could already increase the adoption rate within the development teams. For example, here, we go for a software template with RAG with a hosted LLM. Why would we go for a hosted LLM? Well, let me check this. Most of the time, RAG implementations that we see, it's the application goes to a knowledge base, let's say Elasticsearch, Milvus, Postgres as vector database, gets the most relevant documents, and then sends it to an AI model to formulate an answer on the query that the user is sending to the RAG implementation. The main issue is that the model is outside of your controlled environment, so the data is leaking outside as well. If you now have the model in control, the model is in your own environment as well, so you control everything, the inference server version, model version, and data flows. Why is this important? First of all, that you control the data flows. I think regarding the data breaches, it's important. But version control is important as well, because if you have the same machine learning model, AI model, and you just upgrade the inference server, it can be that the model starts reacting completely different as well. So it's important that you keep in control of these versions too. So here we have an application that will start a RAG application with a custom local LLM. What I forgot to mention, I mentioned local LLMs shouldn't be on your on-prem environment on your laptop. Local LLM can be, for example, in an Azure or cloud environment as well, where you have control on the Kubernetes system, for example. So here we put some names inside, a group ID that can map on the artifact name. We select the model. Here we already had some triage done by our data scientist team. We are allowed to use 3 models. We select an image registry where the resulting application will reside in. And we select a Git repository where the application can be stored, or where the application code can be stored. We review it and we create it. And that's all we need to do to get started with a RAG implementation. I already did this because then have to wait for everything to provision. And it takes 5 to 10 minutes. In the real world, we can go to have a coffee, but not really convenient at a conference. So it then creates the application within your Git system. So I've chosen for GitLab, where you see the code of the application and the GitOps, so the deployment configuration. We choose to split this into 2 repositories. It's just a flavor. You can put it all together as well. So now we can check out this and start coding. To check out, you have 2 options. You can check out on a local environment, but then especially in the AI scenery, it can be that you have to prep your laptop to work with this. You need to have Python of a certain version. You need to have some inference servers and so on. You can as well enable it through a dev space, an IDE which is running in Kubernetes and is then exposing an IDE through Kubernetes through the browser. Disadvantage of this is that you need to have connections to your cluster. So if you don't have internet access, if you don't have VPN connection to your cluster, you can't develop like this. The advantage is that you don't need to configure something locally. And per application, you can have a different workspace, different environment configuration, which is then configured in Git, can be dragged in, and that you don't have to change all these versions, for example. How do we see the adoption of these dev spaces? Well, it's mainly application development itself. Business logic can be developed on local IDEs, IntelliJ, for example, which is my default. But whenever I then go to integration layers, like connecting to Kafka, AMQ brokers, and so on, these are things that I develop in such an IDE, because otherwise I need to open connections to my database, to my Kafka cluster, to my message broker, and so on, which is already exposing security vulnerabilities. While this is running within my Kubernetes system, so I don't need to open any security rules. These templates, these scaffolding templates, where do they come from? Well, it's fairly easy to create them. It's just all stored in Git. If you want to have one, for example, for Quarkus, the only thing you need to do is you create a template file, a template definition, and you create a skeleton. In the template definition, you have two main parts. First one is parameters, which will then resemble the form that you'll see when you want to bootstrap this template. For example, here, the repo name and the repo owner. And then some steps. For example, fetch the skeleton data, transform it with the repo owner and the repo name inside, and then publish it to Git. You can do more advanced things as well, like, for example, and create me a Kafka cluster for this, and create already Argo CD configuration to do the deployments, and so on. The skeleton part then, here you can put the default applications, the primary applications sometimes called, that can be bootstrapped. Why is this important? Well, it can bring now some standardization to your development teams. In the past, when I had to create a new microservice, it was from, hey, that microservice is doing something similar. You can copy paste it, strip the code, and you're good to go. But we removed too little code. And then after half year, it's, why are these classes inside? It's on, I don't know, but it's inside, so it will be doing something right. And technical debt is increasing for no reason. On the other hand, you removed one or two classes too much, and it's, this microservice is not working, what's going on? And you have to debug for a couple of hours, worst scenario, a couple of days. On the CD part, yeah, you copy paste as well, and on dev int environments, if you forget to override some properties, you see it fairly easy, fairly fast. But then the next production release, suddenly the application you copied from was going down. Why? Yeah, suddenly the new application is overriding, deployed over the old one where you copied from. With this standardization side, you avoid all these things. Parameterization is done in this format, for example. Remember, we had the repo name in the forms, in the parameter definition. Well, we just use it over here. These parameters can as well be used, for example, in package names, in your Java classes, in your Kotlin classes, and so on. These translations are done on all the files that are in the skeleton folder. And the skeleton folder is hence not related to just software development. You can put inside, you can put whatever inside that you want, because all these files are just translated. It can be a documentation folder as well. Then we have some game application as well. Here, same format. You give it a name, give it an image registry, give it a Git source repository where you develop from, and you bootstrap it. Everything that's bootstrapped, everything that's configured, listed in Backstage, is available through the catalog. By default, you have the applications, if you configure them so, within your landscape. But you can as well see, for example, resources. Imagine, hey, for my single sign-on, that database, I need some modifications on it, or I need to check for a backup, or I need to check for a new parameter inside. Who's maintaining the database? Well, you already see that's part of the SSO backend application, part of your SSO system. It's, for example, the functional application that you're developing, and user 1 is the owner, and user 1, if you view it in the graph view, and user 1 is part of the RHDH team. So whenever he's on holiday, you can ask his manager or his teammates what's going on with that database scheme. Going back to the applications, here you can enable functionality menu items like you want as well. All these menu items and these menu items are enabled, disabled through the YAML definitions that you store in Kubernetes. First view is a topology view. How is this application deployed in Kubernetes? How does it look like? You'll see for now that I did a fuck up in deployment, so it's not running on any environment. I guess the CI pipeline failed, and we'll see in a second why. So nothing is running. I expect it to run on dev, pre-prod, prod, not yet because I didn't enable it to deploy to these environments. Lazy, I just do dev for my demos. Issues. This is a handy one as well. Imagine you have to wait for a CI pipeline. Now you can link here your Jira tickets, your ServiceNow tickets on the tickets that you're working on in the current sprint, or tickets that you still need to review for the upcoming sprint, or created bugs can be shown over here as well. So you have a clear view when you have to wait for your CI pipeline on what's outstanding, what can already be reviewed, so that you don't forget it. Pull requests. That's one that I was missing a lot in the past as well, because whenever you develop something, the way it went, where I was working is, in the morning during the daily stand-up, it's, hey, my story is done, can you have a look at this pull request? So nothing, someone was going to look at it, around noon, nothing happened yet, in the evening, nothing happened yet. Day after in the daily stand-up, hey, I'm there again with my pull request, do you want to look at it? Yeah, some Teams messages, and then after a while, after a couple of days, your pull request gets reviewed, some minor remarks, but at that time already working on something else, so you have to switch branches, you have to switch environments to get these pull request remarks fixed, to get it fixed, to get it out of the sprint. Here it can be handy as well to work, for example, with these dev spaces, because 9 out of 10 pull request remarks will be minor changes. Just spin it up in an IDE in the browser that you don't have to touch your local system. We're already actively developing another ticket, for example. To CI, I come in a second. CD is a continuous deployment. For us, it's mainly making use of Argo CD, which have different components out there. Why do we prefer Argo CD over, for example, Kubernetes APIs? Is that this is having retry mechanisms, sync mechanisms, and status mechanisms in place. If you're just using Kubernetes API, it can be that the API call says, hey, it's okay, it's deployed. And you're in the impression that the version that you want is in production, while it is not. With Argo CD, you already have more security guardrails around that. Kubernetes artifacts, images that are pushed. API listing, this is just on this application. For example, the Open API spec for the game application is available over here. And if you have the Swagger UI installed, you can already play with it if security is okay. Added value is on the API side that you have a listing over the teams. So whenever you want to integrate now with an API of another team, you have the API listing from the entire organization, if configured like that, within Backstage. So you don't have to chat with that one developer anymore that developed the API, because whenever you needed information from him, 9 out of 10, he's or sick or in holiday. You already have the definitions now available in a centralized catalog. On the other hand, if you have some more protected APIs that not everybody should use, you can protect all these things within Backstage through role-based access control as well. So going back to the catalog, same thing you have for documentation. You have documentation of this application, and you have a centralized list of docs. Be careful, for documentation you need to inject it, insert it in Backstage to Markdown format. And then we often got the question, do you then rewrite all your documentation that's existing in SharePoint, Teams, GitHub, Confluence, and so on, to be inserted into Backstage? Well, there were two answers. An answer of 1 year ago and today's answer. 1 year ago, it was, no, don't just transform all the documentation you have just for the sake of having it in Developer Hub, in Backstage. It's a single pane of glass. create a documentation page in Backstage where you can refer to more recent documentation in SharePoint, in GitHub, in Confluence. New documentation can be added to GitHub and can be injected like that, but no need to rewrite everything just for the sake of Backstage. Nowadays, we had the Gen AI movement, Gen AI that was arriving there. We see that some companies are using Gen AI to reformat some of these documentation pages to the Markdown format to store in Backstage. So that's a bit how you want to work with it. Most important part here is that you just think about it as a single pane of glass. So not everything should be in Backstage, but everything should be referenced from within Backstage. Okay, I told you that I was going to go to the CI pipeline as well. And I already know why it was not deployed. The pipeline was not triggered, my mistake. So lucky for me, I have it already open over here. Config. Let me do a quick change in the code. Okay, change is pushed, and now the development pipeline, the CI pipeline is running. The CI pipeline is part of what we call a trusted software supply chain. What do we mean with that? Well, nowadays security is getting more and more important with all these AI-generated codes configurations. So we need to make security part of the CI pipeline. In the first stage, nothing special. I hope it's readable as well. So you have the git clone, the packaging. Then source code scanning can be, for example, with SNCC for security issues. Can be with SonarQube for the linting. You have the unit tests, the integration tests, and so on. Then, first element of the secure pipeline is the signing of the images. Why is this important? Well, even if you're using an image with a correct version, if you're using the wrong image mirror, you can still drag in images which contain vulnerabilities. If you sign these images and you pass these signatures to your Kubernetes engine, these engines will then reject images which have another signature, images that are tampered with. If you want to have examples on why this is important, you should as well check, for example, Philippe Bogaerts in Belgium, which is a pen tester who is often working with images with which he can hack Kubernetes systems as well. You want to avoid these things, sign your images. It's a good practice to get it deployed. Second part is SBOM extraction and SBOM validation. SBOM is a software bill of material. It's a list of dependencies, components that are inside your application and your container image. These lists can then be validated in scanning tools, scanning registries online for known vulnerabilities. For example, with this you could say, hey, the Log4j version that was vulnerable for the Log4Shell attack, well, do we still have this version in our applications? If so, we can avoid it. Then we have some ACS things. You don't need to remember ACS, it's just a security tool that can run on Kubernetes. But here we can scan images at rest and images within environments and environments. So we can here, again in the Log4j example, scan the environment where we're going to deploy to. Is it Log4j dependency still living in one of the applications that's running over there? And is it still available in the container image that we are going to deploy? If it is, we can say now, hey, we stop the build. Or you can say we give a warning. You can work with these thresholds as you want. You can configure them. And then the SBOM magic. And then we go to a sync in Argo CD to deploy it. And then, if I didn't forget to start the pipeline before the talk, whenever the pipeline finishes, you'll have a vulnerability report over here as well that says, hey, these are the major vulnerabilities, critical ones, and then depending on your thresholds, the build can pass or be completely blocked as well. And then on the overview side, you can link, for example, the pipelines to have direct access to the configurations in OpenShift Tekton. and you have the URLs to access the applications as well over here. So everything application related is now configured within Backstage. Quick look on how this looks. Well, in the YAML definitions in Kubernetes, you'll just see here in the plugin definitions which plugins are enabled. For Developer Hub, it comes with quite some pre-installed plugins, but can be HTTP URLs as well. Here you just disable them, and then in other config map YAML definition, you do the configuration of these plugins. Depending on the configurations and plugins that you have configured over here, you have different menu items over here. These menu items need to be defined in the application itself that's getting injected within Backstage. So for example, if we go to the Game Secure application, it will have a catalog info definition with Kubernetes annotations. Whenever we have the Argo CD plugin enabled, for example, and we have the Argo CD app selector annotation active, then CD menu item on the catalog item will appear, and here you link it to which Argo CD application that should be used. It's very flexible, so it means that within the catalog, you're not only limited to the application itself. If you say, hey, this application is making use of SSO, is making use of databases as well, you can make the underlying components Argo CD status over here as well. You just have to add them to the Kubernetes annotations. Then what else can you do with Backstage? Well, you can have an overview on the environments you have. This is now just using Kubernetes. I often get the question as well, hey, if you want to do platform engineering, are you required to work with Kubernetes? Are you required to work with the clouds? No, it's not a requirement at all. The only requirement you have is that the components that you want to integrate with have APIs with which Backstage, for example, can communicate. You require Kubernetes just to install Backstage because it's a tool that can only run on Kubernetes or Podman. But most of the time you see it on Kubernetes. You have a tech radar, where, for example, if people are saying, when do we have MongoDB available? When do we have an Elasticsearch available? What about Java 25? You can say, hey, no need to nag to us. Have a look at the tech radar, where you can say these technologies, these languages are deprecated. These components, for example, AI models nowadays, are being investigated. And then you have an adoption layer of tools, languages, language versions that you're allowed to use within your application development. We already briefly discussed the docs, nothing fancy about it, it's just a listing of documentation. And an orchestrator plugin, which can already put an abstraction layer on top of API calls, for example, for greeting workflow. This can be used, for example, for simple automation workflows to trigger Terraform, Ansible automation pipelines. That's in a nutshell what you can do with Backstage and on a developer platform like Kubernetes or OpenShift. With this, try to have a look, if you're not already doing this, to platform engineering to build your developer platform and portal to reduce the cognitive load for the developers and let IDPs guide you toward the future. So a summary can give you some homework as well if you're bored tonight. Cognitive load demands and demands on developers are ever increasing, so we can reduce it with platform engineering concepts. Developers can be helped through self-service abstraction scaffolding templates, but how you want to implement it will be specific to your organization and your organization's processes. Resources, well, quite some examples that you can follow or read about or view, because there are some YouTube links inside as well. And resources-wise, you have platformengineering.org, which as well has some conferences, has some good talks, topics, blogs about platform engineering and its concepts. More resources, so if you're really bored tonight, you have quite some material that you can read through. And then some slides that I put with a blue background. The first one is how we can get started with it on the Kubernetes sandbox from Red Hat, which is on developers.redhat.com. It's a tutorial that we've written to connect Backstage with GitHub, to have GitHub Actions in place, the website where I have all the blog posts and talks available, and then another repository for RAG-based presentations. Last but not least, we're building a non-Red Hat, so neutral community, which is the Belgian Developer Experience Network, which is as well linked to platform engineering concepts. Because we saw that you have development silos, you have infra silos, you have security silos. But, for example, why are we not allowed to touch production Kubernetes systems? Well, all these messages we want to bring together within this community, but all focused on messaging to developers. So if you're interested in this, we already had 3 events. Next event is at Flow Factor in Contig, 21st of October, where we will talk about Helm charts and how we can test Helm charts. And with this, I want to thank you for your attendance, and feel free to ask questions. Questions? No, thank you.